All right, guys, welcome to chapter 3. We're going to be talking about guarding the perimeter. Now, in our last session, we talked about the policies and building of the physical walls. Today, we're going to be turning our attention to the network edge. We're going to discuss firewalls, zones, and how to defend the boundary between our trusted internal network and the chaotic outside world. So here's our objectives for this chapter. First, we need to define the network perimeter and understand why this is a critical choke point for defense. Second, we're going to master the function of a firewall, our primary tool for access control. Third, we're going to dissect the autonomy of a firewall rule, source, destination, port, protocol, and action. We're going to learn about the structure of our network being put into zones like LAN, WAN, and DMZ. And then finally, we'll apply the industry best practice like default deny and least privilege. To understand a firewall, I want you to imagine a popular exclusive nightclub. The street outside is the internet. It's full of strangers, noise, and even potential trouble. The club inside is the private network. This is where your VIPs and all your assets live. The firewall is the bouncer at the door. The bouncer doesn't just let anyone in. He stops every single person, packet, checks their ID against their guest list, the rules, and if you aren't on the list, you don't get in. It's that simple and that critical. That brings us to a concept of network perimeter, or what we like to call the digital frontier. This is the logic boundary that separates the trusted internal network from our untrusted external world. We treat this as the choke point. By forcing all traffic to pass through this single gateway, we can inspect it, control it, and log it effectively. You cannot secure what you cannot see. So in our defense in-depth model, the firewall represents layer 2. What is it exactly? It is a hardware device or software application that monitors and controls incoming and outgoing traffic based on a predetermined security rule. It acts as the barrier, the blast door, between a trusted network and an untrusted one. So let's break down that process a little better. A firewall operates in 4 distinct steps for every single packet. Step 1, it examines it. It's going to inspect the header information of the packet to see where it came from and where it wants to go. Step 2, it's going to check the rules. It compares that information against your rule book. Step 3, it's going to decide a binary action, either allow or deny. But it's based off the first rule that it finds. Finally, it records the activity so we can review it later. Now, to configure a firewall, you must write rules. And every rule is going to have 5 components. The source IP. Who is knocking at the door? The destination IP. Where are they trying to go? Destination port. Which specific door or service are they trying to access? Like port 80 for the web. What protocol are they using? What language are they speaking? TCP, UDP. Action. What do we want to do? Do we want to allow this or deny it? So here's what it looks like in practice. First, look at the first rule. We only allow any source from the internet to reach our web server on port 443, which is set to allow. So we have anything from the internet reaching 192.168.1.10, our web server, on port 443, and we're going to allow this. But look at the bottom line. This is critical. If the traffic doesn't match any of the rules above, it hits the block all rule at the bottom. The action is deny. This is going to ensure that only approved traffic enters our network. So if you don't reach anything at the top, then anything below it, it will deny you. Now, firewalls don't just block traffic. They're going to help us organize data into zones. And zones, well, they allow us to structure our trust levels, keeping highly sensitive data away from our public traffic. So the first zone I want to talk about is going to be our WAN zone. Now this is going to represent the wide area network, otherwise known as the internet. This is trust level 0. We must assume everything in this zone is hostile. It's the Wild West outside your castle walls, and you never trust traffic from the WAN unless it's explicitly allowed. The second zone is our LAN zone, our local area network. Now, this is a highly trusted zone. This is where your employees, workstations, and internal databases servers live. In our club analogy, this is our VIP lounge. We want to protect this zone at all costs. And then our third zone is going to be our DMZ zone, otherwise known as our demilitarized zone. Trust level medium. This acts as a buffer zone between the dangerous internet and our secure local area network. This is where we place public-facing servers like web servers. They need to be accessible to the public, but we don't want them sitting right next to our confidential payroll server. So, looking at this topology diagram, on the top we notice we have a WAN. This is where the internet connection comes into the modem. In the center is our OPN Sense firewall. It acts as our traffic cop. To the left, we have LAN, which is the 192.168.10.x secure and private network. And to the right, we have our DMZ, which is our 192.168.20.x. It's isolated. Notice how the firewall mitigates every single conversation between these zones. You couldn't get to the LAN without going through the firewall. You can't go from WAN to the internet without going through the firewall. You can't go through the WAN to the DMZ without going through the firewall. You can't go from the internet to the DMZ without going through the firewall. So why do we go in trouble with creating a DMZ in the first place? Well, the problem is the customers need to see our website. If we put the web server inside our LAN and it gets hacked, now the attacker themselves are inside our house, sitting next to our secrets. So the solution was to put the web server in a segregated network called the DMZ, and think of it like a mudroom or a lobby. If the server gets hacked there, the hacker is trapped in the lobby. They cannot open the locked door to get to the inner sanctum, the LAN. So one of our golden rules when it comes to firewalls is going to be the default deny. Okay, it's the most important default deny policy, okay? This means we block everything by default. We're only going to allow ports that are explicitly necessary for business. If you don't need it, close it. This is also called the implicit deny. Okay. The second rule is going to be least privilege. Least privilege is, well, be specific. Don't be lazy and open up all traffic to the server. If the server only needs to update its time, you only need to open up port 123. You can block everything else. By minimizing open ports, we're going to minimize our attack surface. Giving the enemy fewer windows to crawl through means a more secure environment. Our third rule is always going to be documentation. You might know what the rule does today, but will you remember it in 6 months? So comment every rule. Review regularly. Remove old rules that aren't needed anymore. Old forgotten rules that are common. Old forgotten rules are just common security holes, okay? And then never change a firewall rule without approval and a record of who did it and why. So have some change management. Here's a technical detail that trips up many beginners. Top-down processing. Firewall processes rules in order, from top to bottom. First match wins. So as soon as a packet matches a rule, the firewall acts and stops checking. Therefore, you must place your specific granular rules at the top, either priority 100, and all your general deny rules at the very bottom. If you put a deny all rule at the top, then no traffic will ever get through. Because remember, as soon as it hits a rule at the top, it's not going to read the rest of the rules. So here's a tip from the field. Firewall logs are your best friend. When you're setting up a new rule and an application stops working, don't just guess. Check the logs. The logs will tell you exactly what traffic is being blocked, from which IP, on which port. It takes the mystery out of all troubleshooting. So let's look at our war story for today. The any mistake. An admin was troubleshooting a connection issue. To fix it quickly, they created a temporary rule allowing any IP address to access a sensitive server. The mistake is, well, it worked, so they went to lunch, but they forgot to delete the rule. A little lesson in laziness. So what happened next? Well, because the rule was left active, a simple scanner on the internet found the open ports weeks later. Attackers walked right in through the front door, and, well, that was that. So temporary fixes can come permanent vulnerabilities. Never use any when you can be specific, and always clean up your rules. Okay. So our lab for 3.1 on this one is going to be a firewall planning lab. Okay, we've got Wyoming WebWorks. It's a small design company, and you're the security consultant. You need to design the initial firewall policy for their initial office. So first, look at the network diagram. We have one public web server that needs internet access. We have one internal file server that holds confidential information and needs to be private. We have 10 workstations for designers. And we have a firewall sitting between the ISP modem and the internal switch. You need to visualize the traffic flow. So our mission here is to create 5 foundational firewall rules. Remember your default deny rule, so you can assume everything is blocked. You only need to write the allow rules necessary for business to do the function. Think about the web server. What does it need versus what the designers need? Okay. So, pretty much easy here. Here's our template. Here we go. Please use the template for your submission. I want you to be precise. Give me the rule name, the source, the destination, the port, the action, and then most importantly, write a justification. This is like your comment in the firewall, so in 6 months, when you come back to it, you remember what you did. Here is an example to allow public web access. The internet, any. Destination, public web server. Port, 443. Allow. Necessary for potential clients to view our company's portfolio website. Sounds pretty straightforward. All right, so that's going to wrap up Chapter 3. We talked about perimeter defense. The firewall is the boundary between a trusted and untrusted networks. We talked about zones. This is how we can organize our network between LAN, and DMZ to isolate some of our risks. We talked about the default deny, or otherwise known as the implicit deny, and least privilege. And then we talked about keeping our rulebook clean and commented. We got some documentation here. Make sure you do your documentation, otherwise you're going to hate yourself in 6 months when you forgot. Now, that's going to conclude our session on guarding the perimeter. If you have any questions about firewall rules, zones, or the lab, let me know. Next time, we're going to move inside the walls. We're going to be doing Chapter 4 about securing the interior. I'll see you there.